Good evening. My name is Tan Xun Xiang. So today I will be presenting our cloud computing assignment, which is creating a high availability, scalability, and secure web application. So the problem we have here is example university student report web application becomes slow and sometimes unavailable, especially during peak emission periods due to the heavy traffic. So this already create a poor user experience and also affect the admissions department ability to handle large number of inquiries efficiently. So to solve this problem, the system is designed on AWS cloud to provide better scalability, availability, security, and also performance. So our solution supports the main student record operation, such as viewing, adding, updating, and deleting records, while using a secure and high available architecture. So with that in mind, I would like to focus on the infrastructure components that I was responsible for configuring. So I'm responsible for creating the EC2 instance. So first of all, I've used a total of 5 EC2 instance. So the first instance will be the AWS Cloud 9. So which is the EC2 instance used by my AWS Cloud 9 environment. So this one is used as my cloud-based development workspace to run those AWS CLI commands, script, and also load testing. So the second one is the assignment one instance. So which is my initial standalone web server during the early phase of the project. This one is used to deploy and test the student record application on a single machine. The third one will be the assignment task file instance. So which is the application server created after separating the web application layer from database layer. In other words, the application run on EC2 while the database runs separately on the Amazon RDS. So finally, I have two assignment final instance which are used for the high available setup. So this supports scalability and fault tolerance so the system can continue serving users more reliably. So next, I will move on to the security group. So in my assignment, I have used 5 security group. So the first one is the AWS Cloud9, which is attached to the Cloud9 environment and control the traffic. Second one is the DBSS, which is used for the database and ensure that only trusted resource, such as the application server and Cloud9 environment, can access the RDS instance. So third one is the assignment EC2. So this one is attached to the web server and allows HTTP access for users to reach the web application. So the remaining two are the default security groups automatically created by AWS for default VPC and also the custom VPC. So overall, these security groups help to protect the system by controlling which traffic is allowed between each layer. Okay, moving on to the network architecture, I created a custom VPC called the assignment VPC. So this VPC provides a secure and isolated network environment for the application. So in this VPC, there are two availability zones, which is the US East 1A and also 1B. So in each availability zone, there are two subnets, which is the public subnet and the private subnet. So the public one is used for the internet-facing resource, while the private one are used for internal resource such as the database. So this separation is important because it ensures that the database is not directly exposed to the public internet. To manage the traffic flow inside the VPC, I also use 5 route tables. So the main ones are the public, private 1 US East 1A, and also private 2 US East 1B. So the public one is associated with the public subnets and allows the internet access, while these two private one are associated with the private subnets to keep the backend resource isolated. So the other two unnamed one are the default route tables automatically created by the AWS. So to support the internet connectivity, I also configure one internet gateway and also one NAT gateway. So the internet gateway is attached to a VPC and allows resources in the public subnets, such as the web server, to communicate with the internet. So this is what makes the web application publicly accessible. So for the NAT gateway is placed in the public subnet and allows private subnet resources to access the internet securely for outbound traffic, such as the software updates, so without allowing direct inbound access from the internet. So next for the database layer, I use the Amazon RDS and create a MySQL database instance called the assignment DB. So this database is used to store the student record used by the application. So instead of keeping the database on the EC2 instance as the web server, I separate it into RDS to make the architecture more secure and easy to manage. So this RDS instance this is deployed inside the private subnet, which means it cannot directly accessible from the public internet. So a DB subnet group is configured across US East 1A and also US East 1B. So the database is placed within a secure and reliable network environment across multiple availability zones. So in addition, the database credential will store securely inside the AWS Secret Manager instead of being hard-coded into the application. So this improves both the security and also maintainability. So last but not least, I use the AWS Cloud9 as the browser-based development environment for this assignment. So the Cloud9 environment named Assignment Cloud9 was created as an EC2 backend workspace running on Amazon Linux 2023. So it allows me to write code, run scripts, and also manage the AWS resources, and also test the application directly from the browser. So this has helped to make the development process more convenient and efficient because everything will be managed within the AWS environment itself. So that concludes my part, which is focused on the setting up the AWS infrastructure for the system. So I have worked on the compute, networking, security, database, and also the development environment components to create a more secure and reliable foundation for the web application. So with that, I will pass to my teammate to continue with the next part. Thank you.